All right, everybody, this is Mr. Ainsworth. We're going to get into a lesson on how to use what's called point-slope form. Yes, I said point-slope form. How do you find the equation given a couple points using what's called point-slope form? All right, so what we're going to do is that we are going to label the points given first. We're given a graph actually, but a graph and a line, and on the line there are two given points. So there's an infinite set of points, but these 2 points are given. They're called A and B. So let's outline them here. So point A is right here. You go left 3, all right, and then you go up 4. Okay, so this point right here is called -3, 4. All right, point A. All right, point B is down here. You got to go right 3 and then up 2. All right, so this point B is 3, 2. All right, so we have 2 points. All right, A is -3, 4. All right, we're going to line them up vertically. All right, there's a reason for that, and I'll talk about that in a minute. And we got the second point, which is called point B, is 3, 2. And remember, every point is an order pair, x, y. X coordinate first. Okay, so you move right 3 units on the x-axis and then go up 3 units on the y-axis. All right, the question is, what is the slope of the line, number 1? And number 2, how do you find the equation of the line? All right, so that is the main goal here. And our main tool is called point-slope form. All right, it is used when you know the slope and a point on the line, and you want to find the equation, all right, in slope-intercept form. All right, and we're talking about y equals m times x plus b. We're going to express our equation in what's called slope, all right, intercept form. And this is something that you're familiar with because it was in the previous lesson, okay? It's a very common form of a linear function. All right, so in terms of slope here, monter meaning to climb in French, all right, M is for slope. We need to figure out the rise and the run of the line. You know, how do you get from point A to B or B to A? Okay, it doesn't matter which. You just have to go with the flow and follow the grid lines and get from point to point. The rise is a vertical change. All right, if you go up, it's positive. Down, it's negative. The run is a horizontal change. If you go to the right, it's positive, and if you go to the left, it's negative. Okay, so how do you get from A to B? Well, one way is to go down 2, and I said down, so it's a -2. And you go right 1, 2, 3, 4, 5, 6. So right 6 units, and that's positive value. Okay, the other way to do it is you can go above the line. You can go right 6, right here, all right, and then you go down 2, all right. Or you can go from B to A, and then everything would be opposite. Okay, it doesn't matter how you get from A to B. You can even go down 1, all right, and then right 3, and then down 1 again, and right 3, and that'd be a down 2 overall, and a right 6. Okay, so the slope here is going to be, let's see here, in terms of rise and run. So the slope m, rise is -2 because it's down, and then run is 6. So -2, 6. There's your slope. All right, we call that m, not s, but m, because it was the French who decided to design this coordinate plane, not us, okay, from Rene Descartes, okay, and since he was French, he used the letter M for monter, meaning to climb a hill, which has slope, all right, and as usual, you know, you reduce your slope, and you get -1/3. -1/3 can be seen right here, by the way, down 1, right 3, down 1, right 3, so the slope is -1/3. The question is, what is the equation of the line? Okay, now before we get the equation, let's do it algebraically, okay? Now, when I was with you guys in class, I said, hey, subtract up, okay? All right, let me just write that down too. There's a reason for that too. The reason is because, all right, the 4 is the first y coordinate and the 2 is the second y coordinate, and look at the definition. It says y2 minus y1, right? So second y coordinate minus the first. So you subtract up. And then, so that's going to be 2 minus 4 in a minute. And then you got to handle the x coordinates, okay? And you got to subtract up on those too, right? So 3 minus a -3. So it's x2 minus x1, the second x coordinate minus the first one. So the slope here algebraically is 2 minus 4, subtracting up, and 3 minus a -3. Oops. 3 minus a -3. Notice the parentheses around the negative number there. I subtract in each case. All right, 2 minus 4 is a -2. 3 minus a -3, that since there's a double negative there, all right, you get 3 plus 3, or 6. And notice it's the same as over here, negative 2, 6, which is the same as negative 1/3. All right, so algebraically, you get negative 1/3. Graphically, all right, it says graphically right here because you're using the graph, hence graphically, you get the same value. All right, and the slopes must match. Okay, this right here obviously matches up with this right here. All right, they're the same, and they better be the same. If not, you made a boo-boo. Okay, all right. Now the equation of the line. What is the equation of this line? Well, we know the slope and we know the y-intercept already, so we basically know the equation. But how do you use the point-slope form of the equation? All right, so you need to pick a point, either A or B on the line. You need to pick a point that's on the line. You could pick either A or B. It doesn't matter which. Okay, I usually pick the 0, 1. All right, so let's pick B because it has positive coordinates instead of negative coordinates. So if we use point B, okay, which is 3, 2, that represents our given point, so we're going to call it x1, y1. All right, our given point is going to be substituted in for x1, y1. These are called subscripts, okay, and we're going to substitute these values in here in a minute. And at the same time, we're going to substitute our slope. All right, why? Because we need the slope. So we've got a substitute slope right here. All right, so here we go. So we're going to have y minus the y coordinate, which is 2, right here. Notice that y1 is 2, is equal to your slope, which you found to be negative 1/3. All right, and then then you're going to have x minus x1, which is 3. All right, so there you go. Oh, all right, so we substitute our point in. Let me highlight that. So the coordinates came in right here, 3, 2. We substitute our slope in too. M was negative 1/3, so check that out. We substituted in the point and the slope. That's where the name comes from, point and a slope. Point slope form, we try to make it easy. All right, and then you distribute through and you solve for y. Okay. Solve for y, and you want to get it into y equals mx plus b form, slope-intercept form. So you got to distribute through. So you're going to have y minus 2 is equal to negative 1/3 times x. All right. Now a negative times a negative is a positive. So when you multiply negative 1/3 times negative 3, that gives you 3/3 or 1. All right. So you get plus 1 here. All right, and then you add the opposite here to solve for y. So the opposite of minus 2 is a plus 2. And line up like terms. All right, and you get these cancel out to 0 here. Negative 2 plus 2 is 0. So you get y is equal to negative 1/3 x. All right, and 1 plus 2 is obviously 3. And you get plus 3. And this is called slope-intercept form. Y equals m times x plus b, where this right here represents your y-intercept. Okay, and what's cool about this is since we have a y-intercept here, we have in slope-intercept form, you can look at the graph. Okay, and notice that the line intersects at 3. All right, there's your y-intercept. All right, so you can check your work, my friends. The slope of the line is the same as the slope of the line here on the graph, and the y-intercept of 3 is the same as the y-intercept of the line on the graph. Okay, it's where the line intersects the y-axis, hence the name y-intercept. Okay, it's a fancy name for where the line crosses the y-axis. Okay, so this is where the line, all right, crosses or intersects, one of the two. All right, the y-axis. Okay, I misspoke earlier. It's supposed to be the y-axis. All right, because it's a y-intercept. Okay. So let's highlight that right there. All right. And remember, you check everything. You look at the graph, and if the line doesn't cross at 3, then you made a mistake. All right. All right. This has to match the graph. The slope has to match. The y-intercept has to match. I mean, everything has to look good. All right. And that's why I provided the graph in this lesson here, so you can actually graph the line. Okay. Or look at the line and then figure out if your result makes sense or not. Okay, so let's get some experience here. Let's go ahead and let's practice some more here. If you want to pause and play at this point, go ahead and pause the video and go for it, and then check your work. If you still feel like you need some examples here, if one example wasn't enough, then just let the video run. All right, but try to interact a little bit. Pause and play action. Okay, so we got point A right here. A is at let me see, 1 comma -3. All right, there we go. Point B is at 5 comma 1. So let me write that down. So A is at 1 comma -3. B is at 5 comma 1. Right, 5 up 1 is 5 comma 1. All right, and let's calculate the slope. Okay, let's do it graphically first. So from A to B, we're going to go up 1, 2, 3, 4. So up 4. All right, and that's positive. Right, 1, 2, 3, 4. So right 4. All right, so the slope I can already see is 4/4 or 1. All right, because we rise 4 and we run 4, and so 4 divided by 4 is 1. Algebraically speaking, all right, let's get the slope here. Let's take the y values first. As I always say, you got to subtract up and take the y values first. So it's going to be a 1 minus a -3 divided by 5 minus 1. So what is that? Well, we got 1 minus a -3 is 4, because you got a double negative there. Okay, take a look right here. 1 plus 3 is usually 4, especially today. All right, and 5 minus 1 is 4 too, and 4 divided by 4 is 1. So the slope is 1. Now, it doesn't matter whether you use point A or B. It doesn't matter. So pick a point. So I'm going to use point B at 5 comma 1. And remember, it's our given point, x1 comma y1. So let's highlight that. That's where we always substitute our point right here. And the slope is already 1. We know what m is 1 right here. There's your slope. So let's go for it. Let's find the equation of the line. So y minus the y coordinate 1 is equal to 1 times x minus the x coordinate, which is 5. Okay. So what do we have? Well, first of all, distributing 1 doesn't change anything. So I'm just going to drop the parentheses and make it simplified. Okay. Distributing 1 doesn't do anything. All right. So simply add 1. And you get y is equal to x. 1 minus 5 is -4, which means that the y-intercept is at -4. All right, so look at the graph here, guys. Look at the graph and make sure this makes sense. And so y-intercept at -4, or 0 comma -4. Okay, and it sure does. It's right here. There's -4 on the y-axis right there. And so there's your y-intercept, and it's looking good. Okay, so I know my slope's correct because I verified it 2 different ways. All right, I went up 4, right 4 graphically, got 1 for slope, and then I did algebraically, got the same value. All right, and again, this must match this. It's the same. So the algebraic backs up the graphical, and then of course the y-intercept here at -4 matches up with the graph here. Okay, so this matches up with this. Okay, the y-intercept of -4. So in this case, the equation is very simple. Y equals x minus 4. All right, now let's try another one here. Okay, at this point, you've already had 2 examples. So let's be smart and let's pause and play the video and interact. All right, so pause and play. All right, pause the video and then press play when you're ready. All right, and then you can check your work. And this one's a little bit more challenging because you got, I think, a fraction involved here. It looks like the y-intercept's a fractional, so get ready for that. All right, pause the video, go for it. Okay, let's get the slope first graphically. I'm going to go from A to B. I'm going to go up 2. All right, that's positive. All right, right 4. All right, so I can already see the slope is equal to 2/4 or 1/2. I also see that right here too. I can go right 2 and up 1. All right, and that is the same slope. All right, 1/2. So you can get the slope 2 different ways. We can go right 2 and then up 1. All right, now what is A? A is -1 comma -1. -1 comma -1. I'm going to do it algebraically now. Point B is at 3 comma 1. All right, and here we go. We're going to subtract up. So let's draw that up arrow here. Subtract up, starting with the y coordinates, and I'm talking about the second coordinates here. Okay, so my slope's going to be 1 minus negative 1, divided by 3 minus negative 1. Notice how I put the negative numbers in parentheses. Okay, I have double negatives up top and down below, so I cancel them out first. And what do I get? I get 2 divided by 4, which is 1/2. And so my slope is 1/2. Always simplify the slope. Okay, now I have to pick a point. I can pick either A or B. Picking the one with the positive coordinates is easier. So B is 3, 1. I'm going to label that x1, y1, and now I'm going to get started. Okay, so my x1, y1 is the given point. All right, whatever point you pick, you choose. So you have y minus 1 is equal to slope, which is 1/2, times x minus the x coordinate, which is obviously 3. Just look right there. Okay, distributing through the 1/2. Okay, here we go. So we have y minus 1 is equal to 1/2 times x, which is, that's simple, it's 1/2 x. And then 1/2 times a negative 3. So 1/2 times negative 3 is negative 3/2. All right, all you do is multiply the numerators right there. Okay, and negative 3/2, well, that's, guess what? Negative 3 divided by 2 is negative 1.5. All right, look at this. All right, divides once. Subtract, you get 1, so it's 1 and 1/2. So minus 1 and 1/2. Add the opposite, and you get y is equal to 1/2 x. Okay, 1 take away 1.5 is negative 1/2. And there we go. Okay. Now this represents your y-intercept. Okay, at 0, negative 1/2. Okay, it's where it meets the y-axis. Okay, and let's see if it does. Let's see right here. Okay, that point is the y-intercept. All right, at negative 1/2. All right, that makes sense. So between 0 and negative 1 is negative 1/2. So this is looking good. All right, this y-intercept. All right. All right. Let's keep on going and get some more practice here. All right. All right, pause the video one more time and get started. Okie dokie. All right, so from A to B, I'm going to go down. Let's see here. Let me count. 1, 2, 3, 4, 5. Down 5. All right, that's a negative. Right 2. All right. Notice how I put arrows and shows the direction. It's anybody can easily see that I'm going from A to B here just by looking at the arrows. All right, and so show the direction from A to B, and then that will determine the sign of the answer. So I went down, and that's a negative. I went right, and that's a positive. So my slope, all right, is negative 5/2. All right, from A to B. Now A is negative 1, 3. Negative 1, 3. That's point A. Point B is 1 to negative 2. Okay, so let's write that down. So negative 1, 3, B at 1, negative 2, and we subtract up. All right, as I always say. So because you got to take the second y coordinate and subtract the first. That's why I say subtract up, because it makes sense if you think about it. So m here, slope, is negative 2 minus 3 divided by 1 minus a negative 1. Well, if you add the opposite here and add the opposite here, you get the slope. Let me see, a negative plus a negative is a bigger negative, so negative 5, and then 1 plus 1 is 2, and you get the same thing. Oh my God. All right, look at that. It's the same. All right, and it has to be. I don't care whether you do it algebraically or graphically, it better be the same. And if you're watching this video and going, hey, I got the graph, the slope, differently. I went from B to A. Well, you could do that. Okay, you can go up 5, all right, right or left 2, and you get 5 divided by negative 2, which is negative 5/2. It's the same thing. I don't care where the negative sign is. Okay, 5 over negative 2, negative 5 over 2 is the same thing. All right, so let's pick a point here. I'm going to pick A, just for funsies. All right, so negative 1 comma 3, we label that x1 comma y1. All right, and we get started. Not y equals y minus. So y minus the y coordinate here and here. Okay, so y minus 3 is equal to slope, negative 5 halves. All right, times x minus the x coordinate of negative 1. Okay, so we got to distribute through a fraction, no big deal. Before we do, though, we should cancel this out. All right, there's a double negative there. So I'll go plus plus. All right, and then start distributing. So negative 5 halves times x. All right, and negative 5 halves times 1 is just negative 5 halves. Now, before we add 3, I'm going to simplify this. 5 divided by 2 divides 2 times. All right, remainder 1, so it's negative 2.5. So I have y minus 3 is equal to negative 5 halves x. All right, minus 2.5. And the reason why I did that is because I'm going to have to add 3 now. And it's a whole lot easier to do in your head now. So y is equal to negative 5 halves x, and 3 minus 2.5 is just a half. All right, if you have 3 pizzas and you take 2.5 away, then you have a half remaining. And guess what? That's y-intercept at 0 comma positive 1/2. All right, and that makes sense. It's right here. Okay, that's 1/2, and there's your y-intercept right there. Okay, that's where the line meets the y-axis. That's why we call it a y-intercept. Okay, we only have 2 more to do. So again, go ahead and pause and play, and do it first, then check it with me. That's the best way to learn. Okay, here we go. So A is at negative 3 comma 0. B is at right 3 up 3. So slope. You can go up 1, right 2 to get your slope. Up 1, right 2 to get your slope. Up 1, right 2 to get your slope. So 1, it's going to be 1/2, or you can do it this way. You can go up 3, right 6. So up 3, right 1, 2, 3, 4, 5, 6. Okay, so the slope, if you went from A to B, you get 3/6. But if you went from point to point on the line, like A to this point here, you go up 1, right 2, you get 1/2. And guess what? That's the simplified slope. Okay, so the slope's 1/2. Okay, it's kind of like the staircase effect. Okay, just point to point, and then you get your slope. Algebraically, let's do it. So negative 3 comma 0, B is 3 comma 3, subtract up. So 3 comma 0, starting with your y values, always. Okay, and then divided by your x values, 3 minus a negative 3. And you get the slope of 3 divided by 6, because there's a double negative down below. 3 plus 3 is usually 6. And that means you get a slope of 1/2. You got to simplify your slope. Okay. All right, now let's pick a point. Let's pick B. So 3 comma 3, that's x1 comma y1. So here we go. Y minus 3 is equal to 1/2 times x minus 3. Distributing through, you get y minus 3 is equal to 1/2 x minus 1/2 times 3. Now 1/2 times 3, I've done this before, is 3/2, which is 1.5. So you subtract 1.5 here. And then you add 3. So y is equal to 1/2 x, and then, of course, what's 3 minus 1/2? Well, let's see. 3 minus 1 minus 1/2 is 2 minus 1/2, which is 1.5. All right, just think pizza. All right, plus 1.5. And there's your y-intercept. Okay, at 0 comma 1.5. And that makes sense because right here where the line crosses the y-axis is at 1.5. There's your y-intercept. Okay, so everything's matching up. The y-intercept matches, the slope matches, it all matches. Okay? And that's why the graph is so nice to have, is because you can make sense of your answers. I mean, if your algebraic results don't match up the graph, well, then you made a boo-boo. And then you have to go fix it. Okay? All right, last one. Here we go. We got A, which is negative 3 comma 2. Negative 3 comma 2. We got B at 3 comma 0. All right, and let's find the slope. So we can go right and then down. So 1, 2, 3, 4, 5, 6. Okay, so right 6, down 2. So the slope would be negative 2, 6 or a negative 1/3. Okay, you can also see it like this. You can go right 3 and then down 1. All right, that's the same slope. Right 3 down 1, it'd be negative 1/3. Okay, algebraically, A is at negative 3 comma 2, B at 3 comma 0. Subtract up. So we got 0 minus 2 divided by 3 minus a negative 3. All right, and that is equal to negative 2 divided by 6. So that verifies the slope at negative 1/3. Okay, now let's pick a point. I'm going to pick B. All right, B is 3 comma 0. There's my x1 comma y1. All right, so we have y minus 0 now is equal to our slope of negative 1/3 times x minus the 3, because x1 is 3. Okay, y minus 0 is just y. Okay, I always pick the point with a 0 involved if there is one, because it's easy to deal with. All right, so negative 1/3 times x is negative 1/3 x. A negative 1/3, all right, times a negative 3 is a positive 3/3 or 1. All right, so go plus 1 here. A third of 3 is 1. And a negative times a negative is a positive. Okay, all right, so this line better intersect the y-axis at, okay, 1, or what's called 0, 1, which it does. Okay, the y-intercept is right here. All right, at 1. All right, so there's your y-intercept at 0, 1. And that makes sense. Okay, so this result here matches up with the results on the graph. And that's how you use point slope form, my friends. It is used in a wide variety of applications. So go ahead and get good at it, because this right here is probably one of the main concepts of the entire chapter right here. This is an important one. All right, so if you need to listen to it again, all right, it's a video. Pause, play, rewind, okay, re-listen to it. And do your best. I'll see you in my next lesson, Mr. Ainsworth. I'm out of here.